not be possible. So what I'll try and focus on today is to talk about everything that we've done with iOS XR on the zero-touch provisioning aspect, some of the stuff that's new, and of course, some things that are coming up in the future. So we'll talk about all of that and give you sort of headway into what's going on, at least in this space. So before I start off, I'm Akshat Sharma. I'm a technical marketing engineer. I work on iOS XR architecture, DevOps, requirements around operations primarily. And ZTP, frankly, plays a huge part in determining what our operational lifecycle with iOS XR tends to be, specifically when we go into large-scale service providers and web-scale service provider customers. Right, and it sort of goes without saying that the concept of zero-touch provisioning is not new, and a lot of people have been delving into these set of concepts for a while, whether it's in core service provider domain or in data center, primarily with the web guys. So what I'd like to actually cover as part of this is to show you what we have on XR today, and we'll start off with that before we delve into some of the pieces that are coming up. Usually, whenever I start with the changes that we've made in XR over time, there is an allegorical reference that I usually like to use, specifically with a story that's quite well known. It's a Chinese folklore called A Journey to the West. And it was, at least in the context of Xuanzang, with the extended account of whose travels to India were actually written down in this particular book called The Journey to the West. And while it has a whole lot of folklore associated with it, one of the main aspects that it actually covers is this sort of Neo-Confucianism that spread throughout China, primarily through a mixture of this spiritual renaissance that the concepts of Buddhism brought in as they mixed with Confucianism. And the reason I bring this up is because I see a lot of the changes that have happened within the vendor space, specifically with software stacks, as pretty much of a similar spiritual renaissance in terms of the things that we've been able to build from scratch, starting from a very bare bone, not very automatable operating system to a system that is able to integrate with a wide variety of tools and capabilities and operational life cycles that our customers are expecting. So I treat the effect of some of these web customers as a very similar sort of spiritual renaissance that's been happening in a lot of the vendor stacks, including iOS XR for the last 3 to 4 years. And it goes without saying that there are numbers to back this up, right? So we've actually seen that the actual deployment from truck to live traffic, that is service activation, has dropped to 15 minutes in some of the web service providers. And this is very critical to understand. What we're really talking about here is that everything from the stage that you power on the device to it actually getting the configuration, activating all of the services, hooking up to the monitoring tools, making sure that you're able to gauge what the device is doing once it's up and running. That entire process is meant to take only a matter of around 15 minutes. And this is what's happening in some of the large-scale service providers today. At least that's the mandate. Right? And the only way something like that is actually possible is if you're able to get everything from the instant that you power on the device till it starts sending you data to be completely automated, right? And ZTP, or zero-touch provisioning as we call it, basically plays into the first few minutes of that entire life cycle. How do we make sure that the device that has nothing on it is able to power on, discover its environment, get all of the details that it needs, and bring itself up to a state where it can hook up to other services that are already running. And therefore, if you start also considering some of the web scale numbers that we've seen primarily on the data center side, particularly in terms of the server to the admin ratio, we've seen that grow considerably over the last decade or so. Right, so we are at around 50,000 servers per admin, at least in the data center space for servers. And what that really implies is that the only way a single sysadmin is able to handle 50,000 servers at a time is if they've completely automated the entire lifecycle. That includes the initial PXE boot right up till the entire instance is able to communicate with the rest of the system. And if you start looking at, in fact, the NetOps numbers, in web, they're starting to go up to 3,000 network devices per engineer. And therefore, the numbers are matching up in terms of the complexity that you've seen on the data center side with servers, right? So it sort of goes without saying that if there is no ZTP, there is no real way in which these numbers can be achieved by any network admin trying to run the network, right? So we have to look at ZTP primarily from the perspective of these numbers and the scale that some of these customers are working with. And therefore, it's fairly obvious to say that the concept of NetOps and DevOps is not really two distinct concepts. A lot of people have spoken about it in that regard, where they treat NetOps as maybe a sort of corollary to the idea of DevOps. But I think of them as concepts that have completely blurred, at least in the web domain, and they have begun to blur in the large-scale service provider domain. So we will look at some of the aspects associated with scale, not only on the data center side, but also how it affects some other parts of the service provider deployment, particularly the access market as we go further in this talk. So to start off, what does zero touch with iOS XR in particular actually entail? Remember, I spoke about the fact that I'm going to power on the device has nothing on it, right? And potentially, it doesn't even have the right software that you want to run running on it at that point in time, right? I could potentially put a particular piece of software during manufacturing, ship it out to you as a customer, but that may not be the exact piece of software that you want to run, right? Maybe you have a particular version you're running for a certain set of features that have been designed for you, or a certain set of bug fixes that you need that are maybe not included in the particular image that that's been shipped with. So how do you get to a stage where you're able to get, one, the right image running on the system, and then get the system to have the right configuration, the right set of applications, etc., running on it as it boots up? So to start off, let's consider the automated installation of iOS XR images in the first place. The environment that's actually needed for both this purpose as well as for the purpose of getting configurations and scripts, etc., to run on the system is pretty much identical. The protocols, or at least the life cycle of the processes that are used for each of those purposes are slightly distinct. So when we look at iOS XR image installation, considering the fact that we've made announcements around iOS XR running on third-party network hardware as well around March of 2018, we also have the option of using ONI as a bootstrap technique on hardware that requires it, right? So if you consider white box hardware, supported white box hardware on which iOS XR can run, you would typically need an ONI compatible installer of iOS XR that's able to run on that system. So that's one format of the artifact. Another format, which is typical for all of the Cisco platforms that run iOS XR, is an ISO, right? So we, on Cisco platforms, we use iPXE. And we've spoken about this a few times earlier, but iPXE essentially is the next generation version of PXE, right? It allows us, in addition to, of course, TFTP, etc., it allows us to use HTTP, HTTPS to be able to get much faster downloads and potentially secure transport in terms of downloading the images themselves. Now, this entire process basically starts off by, with the router, as soon as it boots up, using its management interface to actually send out a probe to figure out what IP it can get, right? So you have to have a DHCP server on the LAN to be able to make this work. Now, bear in mind that none of the production or data ports are active at this point. You need a network OS to actually get them running, right? So typically PXE only as processes will only run on management ports, and therefore this as a process, if in case you don't have an out-of-band network in your environment, then this might not be the way you want to go, right? So typically in those cases, we look at customers that just get the right image burnt in during manufacturing, or they basically carry a USB with the required image and do a USB boot for the devices before it goes on to ZTP, right? So this is particularly for customers that actually have an out-of-band network, particularly on the management side. Now, once you have a DHCP v4, v6 message that goes out, there is a particular configuration that allows you to identify these devices. I'm not going to go into details of exactly what the configurations are, but it suffices to say that we're using a particular set of DHCP options that allows us to identify the device, match its corresponding serial number to the image that you want to return, and then basically use option 67, the file name, in order to let the device know where it needs to download its image from. Right? So the device, as soon as it learns from option 67 what the file name is and where it's located, it's able to then make a request to the web server and then download the image. As soon as the image is downloaded, the iPXE process will go ahead and make sure that iOS XR then gets installed as needed, and if required, it'll reboot the system to make sure it comes to the right state. Right? So this is the device coming up from scratch. It may have whatever image it needs, but if it boots into iPXE, then in that case, it will perform this process to download a new image. Now, bear in mind that if there is already an image, it can boot to disk directly, right? And in those situations, there are a couple of things we typically do. ZTP always runs whenever a box boots up and there is no configuration on the system, right? So the idea is that the device is trying to get to a particular service state when it recognizes that there is no pre-configured state on it, right? This is why when we get to ZTP itself, ZTP as a process runs in pretty much the same fashion, and I'll sort of connect the two in just a bit. There are a couple of types of ZTP artifacts that we can consider. This is the stage where the network OS has been installed on the device, it's up and running, and ZTP is the first process that runs once the device boots up. And the goal here is to make sure that you're able to either get a static configuration so that the device simply comes up to the state that's required, or if you want to do more than just a configuration, you might want to install applications, you might want to install special packages that allow you to use further set of features than the base image allows you to. Then in all of those cases, you typically have a ZTP script that you can run. Now, one of the most powerful aspects of what we've done with iOS XR over the last 3 to 4 years is primarily opening up the shell to end users. You're able to basically become root in the shell and hence can run whatever scripts you need. You've bought the box, so you have access to it. You can run the tools that you need, right? And the idea there is that we allow you to run a large bunch of different types of scripts, right? You can do bash scripts, Python scripts. You can run your own binaries, whether they're compiled for Golang, C++, or even PyInstaller for that matter. And the goal here is to make sure that you're not curtailed by the environment that the box gives you in terms of what you can run. It's basically a Linux box. So if you're able to compile whatever tool or script that you have that needs to run on the system when it boots up and it is able to run on a typical Linux system, it should be able to run here. That is the primary goal of how we've designed this entire paradigm. And essentially what happens is that in much the same way as iPXE, an initial DHCP v4 or v6 message will go out. In addition to that, because the box has already booted up with the network OS, we also support Slack with this configuration. So you can have an auto configuration for IPv6 for the interface that is booting up, particularly the management interface, so that it can use that instead of a DHCP v6 defined fixed address in order to reach out to, say, an external web server. Now, another very important point to understand is that here we've already booted up the network OS. The data ports or the production ports are up and running. And what we've introduced in the latest version of iOS XR is that we're able to run ZTP on data ports as well. So you not only run an initial ZTP probe on, say, the management port to figure out if there's anything available and I can download. And typically, if the DHCP server is running there, then great, I'll get my message back and I'll be able to download the artifact that I need. But if I instead I don't have an out-of-band network, but I do have my production ports or data ports maybe connected to, say, a DHCP relay through another router, or it's simply connected to another out-of-band network, which is, actually I should call it an in-band network because it is the production port. Then in that case, you can allow the cycling of the ZTP process through individual data ports to also trigger the entire workflow. right? So both data ports, that is production ports as well as management ports, are supported as part of the workflow. And in much the same way, once it's able to again get an option 67 indicating where that particular script is or a config is then able to download it and make sure that it starts executing it. Now, bear in mind that this is a very clean, open process. No one's actually verifying what's happening. The device is not checking what it's trying to run, not at this point in time anyway. And that basically opens some doors for discussions around how do you secure this entire process that I'll touch upon as we go towards the end of this session. Basically, the idea is that the device will start executing as long as it gets an executable as part of the file name. Instead, if it gets a text file, and there are certain shebangs at the beginning of the file that it can check to figure out if it's an iOSXR configuration, then it can use that to simply replace whatever base configuration ZTP starts off with and replace it with the config that it downloads, right? That's the most basic ZTP you can do. Just give a static config file to the box. And in fact, a lot of other vendors do just typically that. Now, the script part is the one that's interesting because you can now do a bunch of things, right? You can start thinking of installing your packages. Let's say you want a multicast set of multicast features, right? Then you need the multicast package that comes for iOSXR, install it and make sure that it is available before you apply a configuration for multicast, right? So it's like an RPM that you're basically installing. Now, in addition to that, you also might want to run, let's say, cron jobs, right? On any other Linux system, you would do that as well, right? So I want to run a job that runs periodically every day in the morning and is able to maybe give me the state of the box, the current configuration, and maybe a state of some of the files of the system, and then export it outside. So this could be a cron job that's running on my system. But how do I set it up? I can basically get a ZTP script to download a cron job or set up a cron job as part of the script itself, and then make sure that the environment is ready when it's booted up. You can also think of other more complicated scenarios. You want to get an application that is a little more complex, let's say the Facebook's OpenR protocol, then you can get a Docker image that is installed, and then you can start running that as an IGP on the system. Or you could get something like a Puppet client, right? Because you want to use Puppet for the next set of workflows, the day one workflows, where you want to manage a large fleet of devices. Then you want the Puppet client on the device to register to an external server. Then in those cases as well, you want a ZTP script to be able to do way more than just apply a static config to the system, right? So those are the options that you're potentially thinking of. And bear in mind, I mentioned earlier that when you boot up the box and if it comes with an image from manufacturing and that's not the one that you want, you can also force the box to go into iPXE using a ZTP script. So the ZTP script, when the box boots up, gets a ZTP script, it checks, am I running the right image? I'm not, then I'll do an iPXE, and that will force the box to go to the previous stage, fetch the right image, install it, and then run ZTP again, right? So you're able to basically force the entire workflow. Even if the image is not right, you can force the entire workflow to go back to iPXE and then start from scratch. Right? So it is an entirely automatable process from the get-go. And this is the basic outlook on the workflow that ZTP and iPXE basically go through. And the focus of iPXE as well as ZTP is that they retry forever. Right? So if you've kept a box, let's say you've basically bought a couple of boxes and maybe you're not going to set up your DHCP and web server environment for another week. That doesn't mean you have to actually make sure you power it on only at the time when you set up those instances. You can power them on, leave them as they are, and as and when you set up your DHCP and web server, the ZTP process or the iPXE process will fetch the required artifact and move on to the next stage, right? So they're continuously running all the time. And as part of ZTP, as you can see from the red arrow that's coming up, if there is any failure in the application of the configuration or in the script that's it's trying to run, it will go back to the beginning of the ZTP process. It will report the error and it will go back. The assumption there is that you will correct it, and if you can't correct it, log in manually into the system using the console and terminate the ZTP process. Completely up to you, right? But if you want to automate it and maybe you're testing it, then in that case, you can rely on the fact that this will retry forever, specifically if your scripts tend to fail. And we've also added a manual option for ZTP, which basically implies that I can have a system that is completely up and running, and I just want to test my ZTP script, then I can just do a ZTP initiate from my CLI, and it will go through the entire ZTP process, but in a forced manner. That is, it will not check whether I have a config on the system. It will simply run and try to do the same thing that it would potentially do if it were booting from scratch. So there are multiple ways in which you can test your environment. You don't always have to reboot the box and go through iPXE to get to a ZTP stage, right? So you can start even with a fully booted box, test out your scripts, then test out the next set of workflows, right? And as you can see, the set of ZTP functions that are potentially possible are, there are a multitude of them, primarily because it's a Linux system and it allows you to run whatever code you really want to run. Right, so if you're looking at on-box automation libraries that allow you to actually set the configuration of the box, whether this is through CLI, whether this is through Yang-based APIs, all of that is possible through the ZTP infrastructure. And when we're looking at the application of the configuration, or as I mentioned, the upgrade-downgrade process, that can be triggered through iPXE itself. Or you could actually use the XR install processes to do it for you. Right? So there are different ways in which you can start looking at upgrade, downgrade processes as part of the ZTP workflows. Now, in addition to that, I wanted to touch upon a new set of workflows that we've introduced that have actually been a big hit with a large number of large-scale service providers.
Can I ask you a question about previous slide before
Absolutely.
you get into that? I saw in one of your previous slides you mentioned that one of the platforms that you could go onto was an ONI-compatible switch for iOS XR. And, read last year you guys were getting into that. Is that a production OS yet as far as a license that's sold to service provider customers?
Well, that's still limited release for a certain set of customers that we're working with, right? Okay. And we're dealing with that on a use case by use case basis, right? So customers select the hardware that they want, they come to us, we do the integration, and then we proceed further, right?
Gotcha, okay.
So as and when it becomes a GA release, then we can potentially say, yeah, it's available for other folks, but as of right now, it's a limited availability.
Gotcha, okay.
Yeah. But yes, in terms of the workflow, you would expect the same workflow as any other white box. So it'll be ONI to start off before ZTP takes over.
Okay, gotcha.
So Golden ISO is actually a very important workflow to understand, because this is where some of the folks feel that they don't want the complexity of ZTP, but they want the option to be able to have exactly what they want as part of the image itself. Basically create a custom image that meets your requirements, and do it when the customer actually gets the box. So we don't actually have to be involved from an engineering standpoint. We provide the tools that allow a customer to take a base image that we publish on CCO, use that along with the tool to create a custom image with whatever artifacts that they want internally, package it up, and then deploy it on the systems. Right? So you can basically start thinking of iPXE, install processes, etc., to get you to the required state without even doing ZTP in that regard. Right? So this is another part that I typically include as part of the ZTP process, because the final concept is the same. You're trying to get the box to your desired state, and you're reducing the number of steps or the number of artifacts you need to use as part of the overall workflow. Right? Now what happens here is that we typically have the base ISO, right, which is what we publish on CCO. So it's the most minimal software image that we publish. It has a certain set of features that are already there as part of the base software, but we also publish a bunch of functionality packages or RPMs. These functionality packages or RPMs could be things like multicast, MPLS, MPLS-TE, ISIS, OSPF, etc., that we publish as separate packages. And therefore, a typical process would be that you boot up the box with the base ISO, run a ZTP script that goes ahead and downloads these packages, installs them before it proceeds further. So in those cases where customers are happy with the idea of running scripts that get you to a desired state, this is a good process. But there are several customers that have been looking to reduce those steps as well, wherein they know exactly what packages need to be installed on the box. So they do an off-box creation of a custom ISO using the base ISO that we publish. So the base ISO is pushed as an input to a Golden ISO tool that we've already pushed on GitHub. And it basically, today, it is able to take RPMs as an input, the set of RPMs that you want to install, and primarily XR RPMs today. And we're working on adding more features to it. And you can also provide a base configuration. What this basically ensures is that the final image that is created has an XR configuration in a certain location that will be used by the system when it boots up. And it will also go ahead and basically place the RPMs that you need within the image so that they get installed when the box boots up as well. So you have a system where you can start creating a golden ISO. I guess I should have removed those animations. But so you can start basically creating a golden ISO that allows you to have a certain combination of configurations and RPMs along with the base image. And the next set of items that we are working on as part of the golden ISO evolution is that we'll also be allowing third-party applications and RPMs to be installed as part of the golden ISO creation. What this basically ensures is that if you have your own application, your own set of clients that you want to run, or even scripts that you typically would have installed as part of the ZTP process, you can do that completely off box and create an image that boots up with that required state. Right? So you've cut down on the entire script running time, and instead you've done all of that off box. That's the basic idea behind the golden ISO.
Quick question.
Yes.
Did you say, I may have missed it, but did you say the tooling to create these is available on GitHub?
It is all on GitHub.
So it's not, you can't use Packer or anything like that, or?
No, it's so.
It's custom.
It's custom.
Okay.
But it's all open source.
Okay.
So you can look at the code and see how it works.
Okay.
Yeah.
Good.
So the basic workflow is this, right? So we've got the iOS XR RPMs, out of which we create an RPM repo, and the base ISO that is published on CCO, or however we relate to a customer. And we feed all of this into the GISO tool or the GISO tool, I don't know how you want to pronounce it, but it's basically the golden ISO tool, which is on GitHub. And this results in the output that combines the RPMs or the configurations, etc., that you want to specify, creates the image, and then you can deploy using either iPXE or upgrade using XR install, right? Based on what state your device is in. If your device is basically just booting up for the first time, you might do iPXE, right? And if it's already booted up, then XR install is a good way of going ahead with it.
So the GISO tool is just a packaging tool, effectively. It takes all these different parts. When that package gets to the router is going to recognize that and understand how to unpack it and install all the pieces and parts.
That's exactly the same way as you install the base image as well, right? So it is nothing but a slightly bloated up version of the base image because you've added some things to it, right? You've taken the ZTP workflow pieces and done it in an off-box manner, that's all. And this is a very typical workflow that is used in data centers for servers. Typically, you will see Red Hat, Ubuntu, etc., all provide their own golden ISO tools. So in much the same way, we're following suit for network devices as well. So after that, you can typically expect the ZTP process, iPXE process to continue, and then download and install the image on the system. Now, then when you come to the next set of aspects around what we've actually done to the libraries that ZTP provides, you'll be able to see some of the concepts that we've been delving with specifically for customers that are moving away from CLI for most of their operations. Now, one of the biggest problems that we had with much of these systems is that most of the Yang-based API protocols and transports require you to open up a port that you can potentially connect to, that a client can potentially connect to. So to start off, even if you consider, let's say, dealing with Yang-based APIs over netconf, you still need to start up the netconf agent on the box so that it opens up, along with the SSH process, a port that your netconf client can connect to. Now, these lead to a couple of problems. One, we don't want to open up a port by default because those are potential security issues. And secondly, not everyone might be using the model APIs either, right? So we can't force that as a workflow on everybody. So we basically provide a custom on-box capability for you to use netconf against the box without opening up any port whatsoever. This is because of the existing binaries that we have within XR. So it's able to basically provide you a complete NC client style workflow without opening up a port. And the basic idea there is that you have, we're introducing these Yang APIs as part of the 701 release that is upcoming. So currently we're at 652 and the next release will go on to 701. And we will be looking at using the netconf client, which is, I would call it transport free, because it does not open up a port for you to actually connect to it. So the ZTP script that is running locally on the box will simply use the available API to directly pass an XML of the Yang model that it needs to use to the libraries that we provided. It doesn't need to have an entire infrastructure to connect over a port, right? And in addition to that, we're also looking at providing local host-based GNMI capabilities that will allow you to actually use GNMI clients locally on the box, connecting directly to 127.0.0.1 localhost, right? So again, we will not be opening up a port to the external world. Now, in addition to that, when you start looking at the ZTP script options that are available, we started off initially with just the bash library, right? The bash library allowed you to do everything that you can do with iOS XR CLI, and basically add a bunch of things around the capabilities you would typically expect with tools like Napalm, etc., right? So merging config, replacing the config, show commands, exec commands, which are called actions in the netconf parlance. And we added all of that to the bash library. We then moved on to Python and made sure that Python had the same set of capabilities on the CLI side as well. So you can now write certain complex scripts to, again, do what you need to do. And now what we've done is we've added a capability to use Yang in an XML encoded format using the on-box NC client libraries that allows you to basically do everything that a typical off-box NC client could potentially do. So you can do all of the netconf actions, all the opper data that you could gather, as well as affect the state of the system and set it as needed. Now, I've mentioned that some of the GNMI, gRPC stuff is upcoming, right? So, but it is part of the track that we're trying to focus on, right? It will basically open up the port on localhost so that we'll be able to connect and run ZTP accordingly. And binaries are, of course, allowed. So if you want to package up your bunch of dependencies into a single binary, you can do that for PyInstaller for Python. And you can also do the same for Golang and C++. We have a WinRiver Linux 7 Linux environment, and we provide Vagrant boxes for you to be able to compile your own code, right? So we have several examples of that. So we've actually shown how some of these binaries can be quite easily created. And once ZTP kicks off, it essentially just downloads either a binary or a script, doesn't really matter, and it will execute it, right? So if your binary works manually, it should work as part of ZTP. Now let's consider what happens when we come to access deployments. Now I mentioned earlier that ZTP is typically used by the web service providers and the large-scale service providers in slightly secure parts of the network. The reason for this is that ZTP inherently is quite insecure. It's basically getting an IP from a DHCP server, and without validating anything, it's requesting a particular script or a config from some server location that the DHCP server let it know about, right? And there are multiple stages at which this could be potentially taken over. The system could be taken over. And we have to start addressing some of those concerns as we go towards access deployments that are looking to basically deploy a large set of devices. Now, in addition to the security issues, there are also functionality requirements that are quite unique to the access side of the network. One of the typical workflows that you expect as part of any sort of installation of devices, particularly on the access side of the network, is that large-scale service providers tend to use third-party installers or third-party guys that will go ahead and make sure the device is up and running, but they won't necessarily put the configuration on the system. So you will typically have some sort of SMEs that will go ahead and configure the system for you, at least at the pre-staging facility, before it is ready to go ahead and run at the installation site. So there is always a pre-staging facility that you typically go through before you actually go live with these devices. And the basic question is, can you eliminate the pre-staging facility and go directly to the installation site if you're able to have a system that is both able to validate its environment, but also have a well-tested, scripted, automated environment that can bring the device up to the state that you need, right? So we're trying to eliminate pre-staging by making sure that your automation takes care of all the checks and balances as needed. Of course, this is easier said than done, but this is the workflow that most people have to try and move to, particularly on the access side, to get some of the benefits on the OpEx front.
So
yeah.
So I run into this a lot with customers that are doing large-scale deployments. So one of the challenges is in that pipeline of getting the equipment in and then getting an inventory of those devices. So, being able to attach an identity to the device. How are you guys working with customers as part of that ordering process to be able to say, we're going to ship you 1,000 of these devices, and here's the serial numbers that are those devices, so that you can then, in your CMDB and your scripting, start to put an identity to each of those devices, so that when it comes on board, it can actually be provisioned?
Yeah, so that's actually a good question. So there are several paths at which this classification can occur, right? You can do this classification at the DHCP stage. You can do it at the web server stage when it sends a response back to the device. But in whatever stage you do it, you need, as you said, the identifier for the device, right? Now, the serial number is typically relayed to the customer as part of the purchase order, right? Which means that even before they actually see the device, they have the list of serial numbers ready once they purchase the devices. So at least in terms of setting up the devices within at least in the virtual topology, for example, or from the perspective of classification on the DHCP server side, you can do that beforehand, even before the devices reach you. Now, once the serial numbers are identified, as I mentioned, the classification can start either at DHCP or at the web server stage. If you consider DHCP server stage, we have a bunch of options that we relay to the server when the device boots up. We have option 124 that includes the type of platform, the vendor, the serial number, everything in one shot. We also have separate options that also relay the same set of information. And therefore, you can do the classification on the DHCP server side to get it a particular IP, for example, right? You can also use slightly more complex techniques for DHCP, and some customers actually do that, where instead of using a typical ISC DHCP, you use a KR DHCP server. So you have full control over how your DHCP server responds and is not necessarily prescribing to the standard ISC.
Okay.
Right? So there are different ways in which you can start classifying at that stage. And then what happens is once a device gets an IP, you can potentially map the requests that come to the web server based on the IP that it is being assigned. Right? That's one way. Another way could be that you make sure that the serial number context is relayed to the web server itself, right? So when the request comes in, you can actually make the request as part of your ZTP script format, as well as the initial set of requests that go to the web server to relay basically the serial number of the device.
So do it the reverse way, make it more dynamic of request an identity and we'll assign it to you.
Right, so in that case, the IP is not associated with the box, but instead the actual request itself has a serial number. So the IP could be whatever, right? So you have a bigger pool to work with. So just to wrap up some of these pieces here, on the access deployment side, whether you consider carrier Ethernet deployments or mobile backhauls, the huge number of devices that you're dealing with, particularly across the Metro Ethernet cloud, is a big pain, right? And as I mentioned, this is where the third-party installers typically come in. So what basically happens in this case is that we have to look at three functionality requirements for ZTP to actually scale out for this network. One aspect is that you have to have a tree-based build-out for all of these devices. So when the first device boots up and it gets its particular state, it should now start acting as a DHCP relay. So when the next device is connected to the network, it sends its DHCP request through the first device that is provisioned, relays it to the DHCP server again, and then provisions in the next device, and so on. So every device that gets provisioned becomes a DHCP relay for the next device, right? And that way you can simply start connecting the devices. And remember, this is all logic that you have to encode in your script. Your script has to make sure that when it runs successfully on a given device, it is able to correctly set it up as a DHCP relay for the next device, right? And therefore, it becomes a relay system where finally all the devices in whatever topology you want to connect them are then able to connect and get to their required state from the DHCP server. And security is absolutely critical. And I'm actually just setting this stage up because Dan would be talking about some of the security aspects of what we're bringing in with XR and why that becomes critical. So the access devices are typically in very insecure locations. You will find them on poles, on roads, etc. And therefore, you don't have the capability of using a secure network like, say, a data center where you can have completely unverified artifacts going on different devices. you don't have that luxury on the access network. So there are several security aspects that need to be considered. And finally, VLAN discovery, right? So you have to have a way of discovering the VLANs, because here all the requests are going to be in-band. Most likely you have no out-of-band network for the access network, which basically implies that every device will send an in-band request through a production port, and will then have to therefore discover a VLAN through which this request can reach the next set of devices, right? Therefore, VLAN discovery also becomes part of this. So these are some of the things that we are currently exploring and working on to get ZTP to actually work successfully on the access network deployment side. And pretty much my last slide, security versus convenience is a typical problem, right? ZTP is all about convenience, right? You're trying to automate the entire workflow. Greater the amount of convenience, lower the security that you're potentially dealing with, and vice versa. So we have to get to a stage where we're able to match the requirements based on what your network actually looks like. And because I already mentioned the situation with all my access networks, basically what happens is that there are 3 stages of security that I have to deal with. Client validation, right? So any router that is joining the network has to be validated by the server, so that I don't have a rogue device joining the network. Second aspect is server validation. So the router that's already booted up needs to potentially validate the server that it is getting these artifacts from, the script, the image, etc. Right? So there has to be some sort of way for the device to know who it is owned by and how that is connected to the ZTP server that it is trying to download the artifacts from. And lastly, artifact validation itself. So you've downloaded an image. You have to make sure that that image has the right set of certificates before it can actually go ahead and boot it. So secure boot along with a way of testing the binaries and validating them that you download is part of the overall workflow as well. So client validation, server validation, artifact validation, these are the 3 aspects that we have to cover as part of security, and Dan will actually take a look at those. So I've added some more details around this, and we can probably discuss that separately as well. But the idea is the same. I let Dan actually get into details of how we try and address some of these requirements. But this is something that you have to take into consideration when you come to the access network side, right? So.